In the first question, you are given one molecule, calcium carbide, CaC2, and you are asked to tell what is the type and number of bonds present between the two carbon atoms in this molecule. So, calcium carbide is CaC2. So, this is the carbide ion. This is the carbide ion. So, carbides are obtained when I completely deprotonate acetylene. So, this is acetylene. This is acetylene. If I deprotonate the entire acetylene molecule, 2 hydrogen if I remove, I get the carbide ion. As you can see, the carbide ion contains 1 sigma bond and 2 pi bonds. So, 1 sigma and 2 pi bonds. In the second question, you are asked the intermolecular force of attraction that is inversely proportional to the cube of the distance is. So, which of these intermolecular forces of attraction is inversely proportional to the cube of the distance? Now, if I see ion-ion interaction is electrostatic interaction or Coulombic interaction, which follows the Coulomb's law. So, this force in the ion-ion interaction or electrostatic interaction is inversely proportional to r square. So, inversely proportional to the distance between the interacting species. So, this is from the Coulomb's law. If I consider ion-dipole interaction, what is ion-dipole interaction? There is an ion and there is a dipole. There is an ion, there is a dipole. There is an interaction between the ion and the dipole. This is the ion-dipole interaction. So, interestingly, the force of ion-dipole interaction is inversely proportional to the cube of the distance. So, if this distance is r, then the force is inversely proportional to the cube of the distance. So, again, if I consider London force or dispersion forces, so these are even weaker forces of attraction. So, what is actually London force? If I have a molecules are continuously moving. So, this is a molecule which is continuously moving at a particular temperature. At a particular instance of time, let us consider that the electron density suddenly shifts to this position. A molecule electron density আছে যদি molecule continuously move হয় আছে যদি এটা particular instance of electron density to এটা সাইডে বসে যায় এতিয়া there will be momentary dipole here and there will be momentary negative charge here, there will be momentary positive charge here. অলপ সময় কারণে কয়টা negative charge পাম আর অলপ সময় কারণে কয়টা positive charge পাম। Similarly, বেলেগ এটা molecule তেনে হ'ব পাৰে এফালে মই then negative পাইছো then positive পাইছো, so there will be interaction between there will be a very weak interaction between these two systems, which is London force. So, momentary induction of charges. Molecule move কৰিছে ঘপকে আছে electron density বাঢ়ি গৈছে তেতিয়া it behaves like a very momentary dipole. Common fractions of seconds of time it behaves as a dipole, and interaction between such momentary dipoles is London force. So, London forces are even weaker. The force of interaction between the interacting species in London forces is inversely proportional to 1 by r to the power 6. Inversely proportional to the 6th power of the distance. And if I consider hydrogen bond, the force is inversely proportional to the distance. So, question can be anything. So, you can be asked what is the relation between force and distance in ion dipole, force and distance in London force. All these questions are important for exams. The third question, you are given that the dipole moment of KCl is 3.36 into 10 to the power minus 29 not centimeter coulomb meter. So the 3.36 into 10 to the power minus 29 coulomb meter. The distance between K positive and Cl negative is 2.3 into 10 to the power minus 10 meter. The percentage ionic character of KCl is 1. So we already know that there exists no ionic compound that is 100% ionic. There exists some sort of covalent character in ionic molecules. So what is the percentage ionic character of this molecule? How can we calculate from this term? So percentage ionic character is defined as observed dipole moment by calculated dipole moment into 100%. So if we divide the observed dipole moment by calculated dipole moment multiply by 100, we get the percentage ionic character. So the observed dipole moment is the dipole moment that is measured experimentally. So this observed dipole moment is measured experimentally. That means this dipole moment value that is given to you is the observed dipole moment. So this is the observed dipole moment. Now, what we need to do is we need to find the mu calculated. So we have to find the calculated dipole moment. So how can we calculate the dipole moment? Mu calculated equals to charge into distance. So dipole moment is the multiplication of charge and distance between the interacting species. So charge is, we have K positive, Cl negative. K positive, Cl negative. So one positive charge, one negative charge. So K has positive charge of 1, Cl has negative charge of 1. So 1 electron less, 1 electron more. That means how many coulomb? So single positive means 1.6 into 10 to the power minus 19 coulomb. Single negative means minus 1.6 into 10 to the power minus 19 coulomb. That means yard charge over 1.6 into 10 to the power minus 19, yard over 1.6 into 10 to the power minus 19. So the Q will be 1.6 into 10 to the power minus 19 into, so the distance is 2.3 into 10 to the power minus 10 coulomb meter. So this is the mu calculated. That means percentage ionic character equals to mu observed 3.36 into 10 to the power minus 29 by 1.6 into 10 to the power minus 19 into 2.3 into 10 to the power minus 10 into 100%. So this will come out to be 91%. This will come out to be 91%. That means KCl is 91% ionic. So similarly, in exams, the normally asked molecules are HCl. So percentage, find the percentage ionic character of HCl. If the dipole moment is this one, distance is this one. So what you have to do is you have to find the mu calculated. So mu calculated dipole moment you have to find out. You have to divide the observed dipole moment by calculated dipole moment, then you have to multiply by 100. So you can this for HCl is very common question in exams. In this way you can find out the percentage ionic character of any molecule from magnetic moment data and the distance. So before going to the next question, let us try to understand the set of rules which qualitatively explains or which can be used to compare the percentage ionic character or covalent character of molecules. So these are the set of rules which tells us about the covalent character in ionic compounds. So these are called Fajans rules. Fajans rule. So Fajans rule tells us about covalent characters in ionic compounds. So the first thing that Fajans rule tells us is, okay, so is called polarizing power. The other is polarizability. So one is called polarizing power, the second one is called polarizability. So this term polarizing power is generally used for cations, and this polarizability is generally used for anions. So we have two terms, polarizing power and polarizability. So polarizing power is for cations, polarizability is for anions. Now, higher is the polarizing power of a cation, higher is the polarizability of an anion, more is the covalent character of an anion. Cation or polarizing power যদি বাঢ়ি যায়, anion or polarizability যদি বাঢ়ি যায়, তেতিয়া ionic compound এটাৰ covalent character টো বাঢ়ি যাব. Okay, first the second thing is if I talk about polarizing power, polarizing power of a cation is directly proportional to the charge by size ratio. So for a cation, polarizing power is directly proportional to the charge by size ratio. That means cations having small size and large charge are more polarizing. যিবোৰ কেটায়নৰ সাইজটো কম, চাৰ্জটো বেছি, এইবোৰ কেটায়নৰ polarizing পাৱাৰটো বেছি হ'ব আৰু এইবোৰ কেটায়নৰ কাৰণে কোভেলেন্ট কেৰেক্টাৰটো বাঢ়ি যাব. So if the charge of the cations is same, then the only thing that will be important is size. For example, if I have lithium positive, sodium positive, potassium positive, rubidium positive. So the question is, arrange these cations in the increasing order of polarizing power. So the charge is same. Charge is same. So which cation will have more polarizing power? The cation that has less size. Jar size to কম হ'ব, তাৰ polarizing power টো বেছি হ'ব. এতিয়া লিথিয়ামৰ size to কম. That means polarizing power of lithium will be greatest, followed by sodium, potassium, rubidium. That means lithium, if I take these compounds, LiCl, NaCl, KCl, RbCl. So if I ask you, arrange these compounds in the increasing order of, in the decreasing order of covalent character. Okay, so মই যদি কওঁ এইটা আমাক মই covalent character decreasing order হতাও. So lithium, the anions are same. Anions are same. That means the difference will be made by cations. So you have to check the order of polarizing power. Jar polarizing power বেছি হ'ব, হেতু কম্পাউন্ডৰ covalent character বেছি হ'ব. That means lithium has more polarizing power. That means lithium chloride will be more covalent, followed by NaCl, KCl, RbCl. So this is most covalent among the four. This is most ionic among the four. In the same way, if I consider anions, so anions have polarizability. Polarizability বাঢ়ি গলে covalent character বাঢ়ি যায়. Polarizing power বাঢ়ি গলে covalent character বাঢ়ি যায়. Polarizability বাঢ়ি গলে covalent character বাঢ়ি যায়. So polarizability of anions, polarizability increases when size of anion increases. Anion or polarizability to बढ़ी जाए, जगह size to बढ़ी जाए, और anion charge on anion increases. So anion polarizability ketia bai jabo jetia anion size to bai jabo aru anion negative charge to bai jabo. That means if I consider these four anions F negative, Cl negative, Br negative, I negative. Okay, so the order of size is this one. This is the order of size. Eto size or order. Jodi anion size bai jay tetiale polarizability bai jabo. That means iodine have more polarizability. So fluoride or polarizability apnake kom hobo, iodine or polarizability apnake beshi hobo. That means if I ask you, if I have a set of compounds with the same cation, MF, MCl, MBr and Mi, so four cations, same cations, MM, four compounds, MM, MCl, MBr, Mi. So which will be the most covalent? The M to eki ase. That means difference will be made by the anion. So which anion is having most polarizability? Polarizability kuntu anion apnake beshi? Iodide is the most polarizability. That means iodide will be most covalent. So this will be most covalent. This will be most ionic. Cation or size to komi gole covalent character bai jay, anion or size to komi gole ionic character bai jay. Cation or size to bai gole ionic character bai jay, anion or size to bai gole covalent character bai jay. So these are reverse. Now, so what are the consequences? So if ionic character increases, jodi ionic character badi jay tetia thermal stability badi jay. When ionic character increases, thermal stability increases. When ionic character increases, melting point increases. When ionic character increases, boiling point also increases. Boiling point increases. When ionic character increases, solubility in polar solvents increases. Solubility in polar solvents increases. Okay, jodi ionic character bai jay, thermal stability bai jabo, melting point bai jabo, boiling point bai jabo, aru solubility polar solvent bai jabo. Okay, ionic compounds are more soluble in polar solvents. Covalent compounds will be more soluble in non-polar solvents and organic solvents. Okay, we have four compounds: beryllium chloride, beryllium bromide, beryllium iodide, and beryllium fluoride. So you have to arrange them in an order of melting points. Okay, so the beryllium, this beryllium cation is same in all these. The difference is made by the anions. Okay, so as I already told, increase in the, as I already told, increase in the size of the anion increases the covalent character. Anion size to bai gole covalent character to bai gole. That means here I have I negative, here I have Br negative, here I have Cl negative, here I have F negative. Okay, so the largest anion is I negative. That means BeI2 will be most covalent. That means order of covalent character. Order of covalent character will be BeI2 greater than BeBr2 greater than BeCl2 greater than BeF2. So this is the order of covalent character, and I already told you that point কমি যাব ionic character increase হলে melting point বাঢ়ি যাব so if this is A B C D so order of melting point will be D will have highest melting point because D has highest melting point because D is ionic B greater than C greater than B greater than D so this is the order of melting point more ionic more melting point less ionic less melting point next NaNO2 and NaNO3 so sodium is same difference is made by NO2 and NO3 so here I have NO2 negative here I have NO3 negative there are 2 oxygen atoms here but there are 3 oxygen atoms here that means NO3 negative is larger in size NO3 negative is larger in size since the anion NO3 negative is larger in size that means NaNO3 will be more covalent that means NaNO3 will be more covalent than NaNO2 so this was question number 2 in question number 3 you are asked lithium iodide, sodium bromide, potassium chloride, rubidium chloride. So arrange these in the increasing order of water solubility. Arrange these in the increasing order of water solubility. Okay. So here I have lithium, sodium, potassium, rubidium. Smallest cation that means highest polarizing power I negative, Br negative, Cl negative, F negative so smallest cation with largest anion so here cation or polarizing power to basic anion or polarizability to basic cation has highest polarizing power anion has highest polarizability here cation is larger that means cation has high not cation has low polarizing power anion has low polarizability because the anion is smaller it means lithium iodide will be most covalent character increases if polarizing power of anion increases polarizability of anion increases so this will be most ionic or least covalent that means this is most ionic after that so after lithium I have sodium so if I arrange in the increasing order polarizing power Ni positive greater than Na positive greater than K positive greater than Rd positive if I arrange in the increasing order of polarizability this polarizing power if I arrange in the decreasing order of polarizability I negative greater than Br negative greater than Cl negative greater than F negative polarizability so that means lithium iodide will be most covalent followed by sodium bromide followed by potassium chloride followed by rubidium chloride so this is the order of covalent character that means most ionic compound will be more soluble in water water is a polar solvent that means increase in ionic character means more solubility in polar solvents like water that means solubility in water solubility in water will be RBF greater than KCl one more example. SnCl2, SnCl4. So here Sn2 positive, here Sn4 positive. So the charge of Sn4 positive will be less than Sn2 positive. The size of Sn4 positive is less than Sn2 positive. The charge of Sn4 positive is higher than Sn2 positive. That means Sn4 positive will be more covalent. Sn4 positive will be more covalent because Sn has higher charge, smaller size. That means Sn4 positive will be more polarizing than Sn2 positive. So this is more covalent, this is less covalent. After that, let us see one more example. NaCl and CuCl. So here Na has plus charge, copper has plus 1 charge. So how will you compare now? Usually in transition metals we generally do not compare the sizes of alkali metals and transition metals. So in that case, in what way we can do? Now, so what is the electronic configuration of copper? Equals to argon 3d10 4s1. So if I take copper positive, I get argon 3d10. Okay, I get argon 3d10. So such configuration where all the d orbitals are filled, such a configuration in which all the d orbitals are filled. So 3d orbitals are filled. So for 3d series, that means for scandium group, for 3d series, if 3d orbitals are filled, for 4d series, if 4d orbitals are filled, if 5d series, if 5d orbitals are filled, that means 3d series organized with 3d10 line, 4d series organized with 4d10 line, 5d series organized with 5d10 line. Okay, so if for 3d series I have 3d10, if 4d series 4d10, 5d series organized 5d10 line, তেনেকুৱা কেটায়নবোৰৰ polarizing power to বেছি হ'ব. Those transition metal cations which have fully filled d orbitals in their respective period are more polarizing than the normal alkali metals, alkali and earth metal cations. Okay, যিবোৰ transition metal cation or d orbital go fill ho, completely filled ho, those transition metal cations have more polarizing power. So such a state is called pseudo-nodal configuration. So such a configuration is called pseudo-nodal configuration. That means if I have 3d transition metals, the 3d orbitals are filled, 4d transition metals are running, 4d is completely filled, 5d transition metals are running, 5d orbitals are completely filled. তেনেকুৱা যিবোৰ কেটায়ন হ'ব, সেইবোৰ কেটায়নৰ polarizing power বেছি হ'ব আৰু সেইবোৰ কেটায়নৰ covalent character, সেইবোৰ compoundৰ covalent character বেছি হ'ব. That means sodium chloride will be less covalent than copper chloride. Copper chloride is more covalent because in copper the 3d orbitals are fully filled. Okay. Now similarly, copper, silver, gold. So copper positive, silver positive, gold positive. These three cations generally form covalent compounds, or these cations usually form compounds that have more covalent character. এই তিনটা কেটায়নৰ covalent character বেছি হয় compound. Why? 3d10, 4d10, 5d10, because they have pseudo-nodal configuration. The next question is, which of the following resonance structures is more stable, or which of the following resonance structures contributes more to the resonance activity? So how do you choose the more stable or more contributing resonance structure. So this question is highly important for any exams. For me, at least one question will sure come for sure. Okay. So for general main, general advanced, every exam this question is highly important. So how will you compare between the resonance structure? So which resonance structure is more stable? Which resonance structure is major contributor? So how will you find? So let us take the first example. So this is a conjugated ion. This is the resonance structure. How do we get this from A to from I to So in this way. So in this way I get B from A by electron migration because there is conjugation. Now, so how will you check? So the first thing that should be kept in mind is, so there are a set of rules, you have to check the rules one by one. So you can't use the second rule skipping the first rule. First rule to money, second rule to revolve, second rule to money, third rule to revolve. Okay. So first rule is that resonance structures, these are also called canonical forms. Resonance structures with more pi bonds. Resonance structures with more pi bonds are more stable. This is the first rule. Resonance structures with more pi bonds are more stable. So if I see A, there are there are 2 pi bonds. In B, there is only 1 pi bond. So here 2 pi bond is here, pi bond is. That means A is more stable than B. So the stability order is A greater than B. Now, this is the first rule that should be kept in mind. So let us see question number 2. 2 alcohols are given. So this type of alcohol, so these are alpha beta unsaturated alcohols. So these are also called allylic alcohols. So these are called allylic alcohols. Okay. So this is first, this is the second structure. So how do I get D from C? So by electron migration. Since there is lone pair and double bond conjugation. Okay. So how will you compare? Now, first use the first rule. Check the number of pi bonds. So here I have 1 pi bond. Only 1 pi bond is present here. How many pi bonds are present in this compound? Here also I have 1 pi bond. So that means the number of pi bonds is same. That means this rule can't be used. So the second rule that I will use is charged structures are less stable than uncharged structures. So charged structures are less stable than uncharged structures. So this structure is uncharged. That means there is no charge, there is no formal charge. A C compound to F now formal charge 9, but if I see D, there are 2 formal charges, a negative charge over a carbon and a positive charge on oxygen. That means since this is uncharged, this has formal charges, that means C will be more stable than D. Let's see the third example. So this compound is CH2N2, also called diazomethane. So this is called CH2N2, which is also known as diazomethane. Now, so diazomethane is also a source of carbene. Okay. So these are the 4 resonating structures of diazomethane. order of stability, highest stability to lowest stability. আটাইতকৈ বেছি stability to আটাইতকৈ low stability. Now, how to cope? Okay. So first, let us check the number of pi bonds. যাৰ pi bond বেছি হ'ব সি বেছি stable হ'ব. First, 1 pi. So here I have 2 pi bonds. Second, again triple bond, so 1 sigma 2 pi bonds. So here also we have 2 pi bonds. In C, I have only 1 pi bond. So here I have only 1 pi bond, and here also I have only 1 pi bond. That means A and B are more stable than C and D. Okay, so A and B are more stable than C and D. Why? Because the number of pi bonds is greater in A and B than C and D. Okay, so this is the first thing. Now, how will we compare between A and B? Okay, so A and B number of pi bonds again. First two bonds. Now go to the second rule. The second rule tells you that uncharged molecules are, that means molecules with no formal charges are more stable than molecules with formal charges. So A molecule to formal charges ase, A molecule to formal charges. That means I can't use the second rule also. In that case, I have to use the third rule. Rule 3, that tells me that negative charge on more electronegative atom is more stable. So negative charge on more electronegative atom is more stable. First of all, pi bonds, second one charge, third one jodi charge to ek hoye jay tete ma samjhe negative charge on more electronegative atom is more stable. Now, if I see A and B, या মাজৰ নাইট্ৰজেনটো দুইটাতে পজিটিভ চাৰ্জ, that means মাজৰ নাইট্ৰজেনটো একেই আছে, একো ডিফাৰেন্স হোৱা নাই. Difference is brought by the carbon in the terminal nitrogen. Difference to কোনে আনিছে, এই কাৰ্বনটো আনিছে আৰু এই টাৰ্মিনাল নাইট্ৰজেনটো আনিছে. Okay, so if I consider A negative charge on nitrogen, if I consider B negative charge is on carbon, and as per rule number 3, negative charge on more electronegative atom is more stable. That means negative charge on nitrogen is more stable than negative charge on carbon. That means A is more stable than B. A is more stable than B. Okay. Now let us see C and D. So again, they have same number of pi bonds. 1 pi bond I can't compare it in the first rule. Again, go to rule 2. Both have formal charges. I can't compare them on the basis of formal charges also. Again, I move to the third rule that tells me that negative charge on more electronegative atom is more stable. Here I see negative charge is on nitrogen. Here negative charge is on carbon. Negative charge is on carbon, positive charge on carbon. Negative charge, positive charge on nitrogen, negative charge on nitrogen. In this C, negative charge is on carbon, D, negative charge is on nitrogen. So since nitrogen is more electronegative, nitrogen will bear the negative charge easily. That means D is more stable than C. So after B I have D, after D I have C. So there are 3 rules. First, আমি প্রথমতে কি কৰিলো, প্রথমতে পাই বন্ড চালো, পাই বন্ড সব আমি গম পালো যে A আৰু B, C আৰু D কে বেছি স্টেবল. তাৰপিছত আমি চালো A আৰু B ভিতৰত কোনটো বেছি স্টেবল. A আৰু B ভিতৰত ষ্টেবিলিটি চাবৰ কাৰণে আমি ৰুল নম্বৰ 3 টো চালো. ৰুল নম্বৰ 3 আমাক কি ক'লে, যিটো ৰেজনেন্স ষ্ট্ৰাকচাৰত third rule, from the third rule, we got the order of stability. Again, let us see these two structures. So, which is the major? So the question is, which is the major contributing structure? The structure which is more stable is the major contributing structure. Now, how to find? Use rule 1. Check the number of pi bonds. Here I have 1 pi bond. Here I have 0 pi bond. That means more number of pi bonds. That means more stable. So this is more stable than this one. That means this is the major contributor. There are 5 resonance structures of the same molecule, alkyl isocyanate. This alkyl isocyanate, this molecule is given to you. There are 5 resonance structures. You are told to arrange these in the decreasing order of stability. So from major contributor to the minor contributor. So how will you decide? So first use rule 1, check the number of pi bonds. So there are 2 pi bonds. There are 2 pi bonds. Here also 2 pi bonds. Here also 2 pi bonds. Here also. Here I have 1 pi. Here I have 1 pi bonds. That means A, B and C are more stable than D and E. So A, B and C are more stable than D and E. Okay? A, B আৰু C দুইটা কি বেছি stable. So যদি মই কও A, B আৰু C এই তিনটাৰ মাজত আটাইতকৈ stable কোনটো? 2 pi, 2 pi, 2 pi. That means from first rule I can't decide between these three. I will use rule number 2, which tells me molecules having formal charges are less stable than molecules having zero charge. ইয়াত formal charge আছে, ইয়াত formal charge নাই. যিবোৰ molecule formal charge আছে, সেইবোৰ molecule less stable হ'ব. কাটে less stable হ'ব, যিবোৰ molecule formal charge নাই. So here I have zero formal charge. কোনো এটা এটমত charge নাই. ইয়াত charge আছে. That means A is more stable than B and C. That means পাঁচটাৰ ভিতৰত আটাইতকৈ বেছি stable A. So A is most stable. Formal charge মানে কি? এগুলো যে নেগেটিভ পজিটিভ চার্জ এগুলো these are called formal charges. এগুলো চার্জকে formal charge বুলি কয়. যদি formal charge থাকে তেতিয়া এটো less stable হ'ব, কাটকে less stable হ'ব, য'ত formal charge নাই তাত. So now let us see between B and C. So rule 1, same pi bonds, formal charge দুইটাতে আছে. Let's go to rule number 3. So according to rule number 3, negative charge should be present on the more electronegative atom for more stability. Zero atom negative charge to more electronegative atom থাকিব এবোৰ structure বেছি stable হ'ব. So here I have a negative charge on oxygen. Here I have a negative charge on nitrogen. Here oxygen on negative charge আছে, here nitrogen on negative charge আছে. Okay, so oxygen is more electronegative than nitrogen. That means this will be more stable. B will be more stable than C. Okay, so let us see between D and E. Rule number 1, same number of pi bonds. Gone. Rule number 2, both have formal charges. Rule number 3, which has negative charge on more electronegative atom. So here I have negative charge on nitrogen, here I have negative charge on oxygen. That means E will be more stable than D. So this is the order of stability. So A is most stable, D is least stable. That means A is the major contributor, D is the minor contributor, and these are intermediate. Okay.